Hello everyone, this is Muhammad Javed, lecturer Mathematics, International Maritime College. Today's our topic is about area bounded by a curve lying above the x-axis and below the x-axis. Both of the cases will be done here, inshallah. I hope this session or this video will clear everything. If you have any problem, write down in the comments below, or we'll see each other in the online session. Here is a function y of x, and the area between the curve and the x-axis is required to be determined. So I will apply the basic rule of finding area. If I take a rectangle, then this is length and this is width. This area is equal to width times length area. So the same way, this area is divided into very small rectangles. Sorry, it will be difficult for me, but okay, let's make it a little bigger. And this way they can be divided into large number of small rectangles. Like I can say that it will be like this, very small rectangle. Okay, so it makes this curve does not make any difference, because when the rectangle are very small, and if we zoom it, then we will find them small rectangle, each of it. Well, this is width, all width, 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 and width. So they all are width, same width, very small width, and we write them as dx, and the height usually in the xy plane is y. So the area of this one rectangle will be equal to y dx, y dx, but there are lot of rectangle inside, large number of rectangle. So we are going for integration. Integration means also addition. So all small area we are going to add, all rectangle area we are going to add from A to B. So this integration represent the area. So we are still using this basic principle which we learned at school and we applied at large of occasions or moments. Well, so area is from A to B y of x, because y depends on x, so we write, if you write simple y, and for y sometimes we also write f of x, they are same term, y of x and f of x. No need to be confused with them, they mean the same thing, the height from the x-axis. So this is a y of x at this x. Let's go to example, I think, yes, from the book. This is function, and we are going to calculate area under this curve and between the x-axis from 1 to 4, not the whole area, just between 1 and 4. So yes, this is the function, which is 1 by x. So you want to write f of x, or you want to same thing, and we are asked to calculate area under the curve from 1 to 4 x. So this shaded area is need to be determined. So this is an integral of 1 over x from 1 to 4. So we can say this is the application of definite integral. Okay, so lower limit, I lost my cursor, okay, so this is lower limit, upper limit, and this is the curve, and dx. As I explained, dx is small width of each rectangle. So if you see the table of integration or integrals, it is like this. Now plug in value, we put these bar symbol. If x is negative but the x value 4 is positive, the x value 1 is positive, so here we are not using them. If you use them, so again it will come 4 in the next step. So 1 and 4 are already positive, so we don't need to add this absolute bars. Well, calculator, and then the final answer. So the area which falls in this curve is under the curve, and the x-axis is 3, 8, 6 square, because we write square unit. Okay, unit, because always the unit of the area is square meter, square centimeter, so I'm writing square unit because I don't know the unit here, because in the question nowhere unit is mentioned. If we see from here to here, it is not mentioned, so it's better we write here square unit. SU, huh? Well, let's go further. Another example. Oh, your favorite curve, guys. You were very excited when you were drawing it, and I think it is like this. It was pi, and here it was 2 pi. So it means this is pi by 2, and this is 3 pi by 2. Here it is 1, so the amplitude is 1, and it looks like it will touch here 1, and it will touch here -1. This is 1 and -1. So the curve will be like this, I think. Now, which area they are asking? From 0 to pi. So 0 to pi is this area. This area we are going to know. So, and this is 0. So 0 to pi. Above the curve we are going to calculate. Let's see my neat and clean work. Oops. By the way, I did it in Paint. So yeah, so like this, neat and clean. Solution from 0 to pi. Yes, they were asking from 0 to pi. Integration table, and don't forget to mention the limit. I lost my cursor somewhere. Oops. So it is here. So this is upper limit and 0 is the lower limit, and one time we put here pi and another time 0, and I write this minus outside, and for these two I use bracket. Okay, calculator for radians. Okay, calculator for radians, or pi means if your calculator is in degree mode, so then pi means 180 degree, but I would recommend that change your calculator to pi to radian when you see pi. Well, it's up to you how much you are easy, because some students don't like to change the mode. They do it mentally, and so it's up to you. And it comes to, so the area here from this 0 to here, from this 0, it is 2 square unit. I don't know the unit, so I will be writing square unit. Another example, e2x is a function from 1 to 3. Okay, I'm not drawing a graph for this. Well, you can calculate this with calculator. So if you want to draw a graph for this, I have taught you and you know it very well now. So this is x and this is e2x. If you want to draw a table, so start from 1, okay, and 1.5 give 2, 2.5 and 3, and I think and then you will get values and draw graph. Now EX graph is not in my mind, but I think E0 is 1, so I think it is E01. I hope so. It is like this, and they are asking from 1, 2 and 3. Well, I'm not sure, but I think the graph is like this. I'm sorry I did not practice it. This is 1 and this is 3. If the function is like this, so I think it is e2x like this. Anyway, in the question here you are not asked to draw the graph, but if you are asked to draw the graph, so the table then will help you and then draw the graph, not up to the scale, just give idea. Well, here this is a table of integration, and if you could remember, there it was e of k x integration dx, and it was divided by k and e k x. There was also plus c, but now we are in the definite integral, we have limit, so no need to write this. Look, when limit comes, I told you in the definite integral we are not using this. Well, plug in values one time for the upper limit, then for the lower, and subtraction symbol between these two terms, yeah, and it comes 198 square unit. Okay, let's go to another example. Yeah, very familiar graph curve, and we are going from 0 to this, and the two graphs intersect at the point this. So there are two graphs. Yeah, I didn't see this one. So we are going to calculate area between them. So let's try to draw them. I think it will be better. This is sine, because amplitude here 1 and also 1, and then this will be pi by 2, this will be pi, and this will be 2 pi, and here it will be 270 or 3 pi by 2. Okay. So the cos function will be like this. Yeah. So which area they are asking? The two graphs intersect at a point this where x equals pi by 4. Find the area. Okay, so I think they have given us the okay. So look, this is the area they are asking, and this place is pi by 4. Okay. So from here to this place, this is the area, shaded area we are going to calculate. So area from 0 to pi by 4, from 0 to pi by 4, and this subtraction between them. So first function minus second function. Okay. So if we subtract, so this area will be cut out and the upper area will be left. So one time cosine, another sine, table of integration for pi by 4, and for sine for both limits, then minus, and cosine for both limits, calculator. So this area, this shaded area is 1 4 1 4. Well, next, things, lot of reading. Example 3.5, area under velocity time. Okay, velocity time curve will be like so this line is for time, this line is for velocity. Okay, an object plotted against time t, it means graph is given as shown, there the area under such the graph between t equals, so there are two numbers, a 1t and another t. They may be in hour, they may be in meters, because units are not mentioned here, I think. And we are asking for distance. So look, for example, I don't know about this graph, it looks like parabolic curve. Well, let me see the graph here, then I will give, oh yeah, so So yes, it is parabolic, so it is parabolic. I should explain this one. This is t and this is another t. Both of them will be in the same unit, and this line is for v, velocity. Okay, if you could remember what is velocity, velocity equals displacement divided by time, and then displacement equals to velocity multiply time. So this line, for example, if here are small rectangles, so this small because this is t, so this small width will be dt, and this height will be v. So its integral, or it's the area of one. So this area actually shows that the distance. Look, v multiply t, so v is height and dt is width, so it is small, it is the area of one small rectangle, but we will divide this into many small rectangles. So from A to B, all these area will be added, and that will give us the distance. Distance practically is not given here, but the concept of the area and the concept of multiplication of length and width suggest us that this is actually distance. Now let's see network. So it's state, okay, 1 second. They are question, by the way. They are question, okay? Because I'm going to clean my right side. Okay, so most of the concept I have given, and this is just using value and here t value, so they are not so important. This is velocity plug-in, so velocity after 1 second is 8 meter per second, and just write here t value, which is 1. See, so 1 square, it will be 3 plus 5 8 meter per second square, standard unit. Number 2, this time we are doing for 2, so plug in and 2, calculator, and 17 meter per second. Now we are asking, they are asking about area or the speed, the distance. So I told you that it is v dt, and this is v actually. So v, I write again for you, t from 1 to 2 is equal to this. V equals this 5, 3 t square and plus 5, which is this. And then table of integration. Now applying limit, one time we'll plug in 2, then minus, and then 1. Okay, after simplification, 2 brackets with different limits, with both of the limits, and it's come 12. And what is mistake? The mistake is okay, there is no mistake. Now maybe you ask, why not square, Mister? This is area. Now we saw technically this is here area on the chart, but by concept it is distance. So take care. The graph is facilitating us. It does not mean that practically this is area. So it is 12 meter distance. Exercise. So it will be like x3 dx from 0 to 2. Then go for table of integration and do it. And I think the graph for this x cube is, in exam you can be asked for graph, so you will use table. You draw table x and x3, because we are doing for x3 0, so you do from 0. The gap is your choice, how much distance you keep between them, 1, 2. But the more the less gap you give it, your chart will be very fine. Oops, this is 1 point actually, and this will be 2. So it is 0. Okay, it comes 1 and it comes 8. I'm sorry at the moment for them, you do it. So it looks like it is curved like this. So this will be 1, this will be 2. Okay, 1 and 2, but this is asking from 0, so they are asking from 0 to this all area. Okay, so try it. Now come for this one, y equals t square 3t square. It's a parabolic function, 3t square. So it will be like it will be like this. So 1, 2 and 3, so minus 3 because on the left side, and 1, 2 and 3 here. Here it is touching 0 actually. So which area is required? Some of the areas on the left, some areas here. So this area you are going to calculate, and this will be that is not x. It is 3t as function, 3t square. Okay, and the width, so this is function height and this is width, and now we are doing for all the small pieces from -3 to 3 equals table of integral, and then plug in value. So I hope if you can do it now, but I will suggest when you are doing it, try to draw them. You have learned how to use calculator and how to draw them. Okay, let's move on. The area bounded by a curve, parts of which lie below. Okay, so this curve. Okay, so first of all, this curve will be crossing x like this. So we need to, its power is 3 degree 3, so it will be crossing the curve in 3. It will be crossing the x-axis at 3 points. So first of all, we should find these points, then we can say, or we can find this lower area, because they are asking for total enclosed area. So some area is on the curve and some area is below the curve. So take out x common, then factorize it, and then x has 3 values. So 0, yes, this is 1, this is 4. Okay. Yes, here is fine graph given in the book. So this was 0, this point. So we will find this area, and then from here to here. Because they are not asking for 4, they are asking only from 1 to 3 or from 0 to 3. So now this time we will do 2 integral. First integral is from 0 to 1, and second integral from 1 to 3, and of course for the same function y dx. Same concept. Here are small rectangle, here also small rectangle, and with the same d. So this is also y d and x. Okay, let's see now then clean slide board. Okay, this is for help. So look from 0 to 1, this is y and this is dx. I mentioned earlier y and dx. So I'm going to do the first one, which is on the curve of, this is 1. So this piece I'm doing first, and after that in the next one this will be done. So table of integrations, plug in the limits, and it comes 7 by 12. And note that there this is plus. Okay, now if the area is under the x-axis, the result will be coming negative. So negative tells us that this area is under the x-axis, and technically area can never be negative, but it is for the representation that it demonstrates that area is coming under the x-axis. So let's go from 0 to 3 now. 0 to 3, the same function, applying table of integrations rules, limits, and you see minus is coming. So this minus is an indicator that it is coming under the. Now total area will be equal to, look, I'm not using minus here because it is just a symbol for the area. It is coming under the x-axis. Another example, sine 2x. So here amplitude is 1 and time period, if you know. So time period for sine of x is 2 pi. So we will make them equal, 2x equal to 2 pi, because sine completes one cycle and 2 pi. Okay, this is pi and half of it is pi by 2 and this 3 pi by 2. Okay, so period has come out. Now the period of the new of this sine 2 is, it means it will complete its one cycle in radian angle. So half of it is pi by 2 and half of this is pi by 4, and this middle point is 3 pi by 4. Now what is the question? The question is to calculate the total area, from pi by 3. So pi by 3 and 3 pi by 4. Where is my cursor? Okay. So one integral is from pi by 2 to 3 pi by 2. So this, okay, and 3 pi by 3 falls where? Pi by 3 falls somewhere in this locality, I think. So this is the area. Look, this total is pi. So if you divide this into 3 parts, so this is pi, so this becomes pi by 3. So yes. So, and another is from pi by 3 where the x-axis is crossed at pi by 2. So two areas we are going to find, one on the curve and another below the curve, which cross x-axis at 0. Look, this is 0, another is pi by 2, this is pi by 2, this point, and the last is this one. So it cross the x-axis at 3 points. So for the required area from pi by 3 to pi by 2 is above axis, clear. And then from pi by 2 to 3 pi by 4, I should have written here 2 not end. Where is my cursor? I cannot see it. Okay, this is supposed to be 2. Okay, and this is neat graph. Okay, so it took a lot of time for me. Anyways, I also done with marker. Okay, so from I mentioned this, that there are two integral. So this area from pi by 3 to pi by 2 is this integration, and then from here to here is this integration. Table, calculator, table, simplification, and see this guy. Okay, so no need to be mistaken, it just shows that it is the curve is going under the x-axis and it is the area under the x-axis. But when you are doing total, so remove that minus and put plus, and yeah, so this is area square unit. Next exercise, so you should try them. Answers are given. I will upload this the answers of these questions, practice them, and they are typically exams questions. Most of exams we find this kind of questions. Well guys, if you have any query, any problem, any issue, you can come online and ask me in our class time according to college timetable.